We are a materials science and engineering senior design team, and we are working with Mercury Marine to design a shot sleeve insert for the high-pressure die casting of steel. Steel is not currently used during high-pressure die casting due to its high melting temperature. There is experimentation of steel high-pressure die casting, but commercially, aluminum, zinc, and magnesium are being used. During steel high-pressure die casting, molten steel is poured into an H13 shot sleeve where a copper beryllium plunger pushes the molten steel into a die cavity. The problem we are seeing is the high temperature of the molten steel being poured is causing the H13 shot sleeve to have a concentration of heat directly beneath the pour hole, increasing the temperature during each cycle until it melts and fails. To avoid shot sleeve failure, a temperature-resistant material will act as an internal liner. This way, the H13 shot sleeve will not fail due to the higher operating temperatures of the lining material.
Materials with melting temperatures higher than H13 were selected as material candidates for the internal liner. Thermal shock resistance was evaluated for H13 and 4 monolithic ceramics. Of the 4, boron nitride was the only material that survived thermal shock. 3 refractory ceramics were also selected for testing. Simulations were conducted to analyze temperature at the bottom of a test plate that would be in direct contact with the shot sleeve. The pour cycle that reached the highest temperature for each material is labeled below. A mold design was made to test the candidate material's response to the pour cycles with stainless steel. Thermocouples were used to measure the temperature of the candidate material and the molten steel being poured during each cycle. Physical trials were performed using the mold seen on the left. During each pour, molten steel was held in contact with the material for 6 seconds before being poured back out. As mentioned before, the thermal shock resistance of silicon carbide and mullite did not withstand the effects of molten steel. During physical testing, this held true and they both failed within seconds of coming into contact with molten steel. 3 materials, boron nitride, Alicast 90, and Duracon 32, did not fail due to thermal shock during physical testing and simulated testing.
Moving forward, wear testing of each material is required to simulate the effects of the plunger during high-pressure die casting. Manufacturing of the liner with a successful material is also needed. We would like to thank our sponsor and everyone at MTU who has helped us along the way.